In Algebra 2, Section 2.6, we're dealing with special functions. So, with special functions, basically, there are different types of graphs that you're going to be dealing with. So, an introduction is the first one is called the piecewise function. And to make it simple, what you need to see a piecewise function is basically two graphs in one. So this tells you the graphs. I have two graphs. This is the first one, y equals. The first one is y equals x minus 1. And the second one is y equals negative 1. All right? Now, this tells me where on the graph I'm going to have. So on x, so here's my x, here's my y. On my x, so 1, 2, 3, right here. So anything smaller than x is going to be here. So this is going to be on the left side of that line, and this is going to be on the right. Okay? So I'm only going to graph using x's that are equal to or less than. So basically, I'm going to graph using a table. So x, y, and my equation is x minus 1. So I'm going to find x's, but they have to be either 3 or less. So 3, 0, negative 1. Let's do that. So 3 minus 1 is 2, 0 minus 1 is negative 1, and negative 1 minus 1 is negative 2. So I'm going to graph 3, because this is, or equal to, means that 3 is included in this one, but it's not included in this one. So I'm going to do negative 1, 3 to, 3, positive 2, my first one, 0, negative 1, negative 1, negative 2. So here's my first line. It'll continue this way, but it won't continue that way. That's only why I'm using the arrow for 1. The next one is pretty easy because there's not really a table we have to do. It just means y will stay 1 the whole time. So no matter what this is going to be, y is going to be negative 1. So when this is it, I'm just going to find negative 1 on y, right? And I'm going to draw it. If I didn't have a piecewise function, I'd start here and keep going. I mean, I do the whole line here. But because it only counts for things that are bigger than 3, I'm going to find negative 1. I'm just going to start here at 3, but I'm going to put an empty one, not a closed like this one, because this one is included. I'm going to put an empty one, and I'm just going to put, no matter what it is, anything bigger than 3 will be greater, okay? The next one is called a step function. It says, one psychologist charges for counseling sessions at the rate of $85 per hour or any fraction thereof. Graph the situation. So that means that one psychologist charges for counseling sessions, so for every hour. So I'm going to put hours here. I'm going to focus on the positive because you're never going to do a negative hour. So I'm just going to focus on this positive area. And it's going to be 1 hour, 2, 3, 4, right? And then depending on the hour, how much it is. So we're going to go by 85. Okay? What this means, at the first hour, the person is going to charge for counseling through $85 or any fraction thereof. So if the person goes from $85 and goes less than an hour, they'll be still charged by 85. So for the first hour, it's going to be 85. Okay? So no matter what, even if they do 45 minutes, it's still going to be 85. If it's going to be 35 minutes, it's still going to be 85 because it counts as a first hour, even if they don't take up the whole hour. That's what that's saying. The next one, after an hour, even if it's just an hour and 5 minutes, you still get charged for 2 hours. Okay, they're rounding up. So you get 2 hours Once you hit 2 hours, then it goes up again. So these are called step functions. Right? Because it's going to be $85 all the way through, even if you don't make it for full hour. That's what step functions are. So piecewise functions are 2 graphs in one, and this tells you where you're going to split the graph. And then these are step functions because it counts for everything. And go ahead and pause it and write this down. We have one more function, and then you're done. So go ahead and write this down. So the next graph is an absolute value. Remember, in the absolute value, anything on the inside is positive. And I'm going to graph this simply by using a table. Okay? The absolute value graphs as a V. So I'm going to keep going until I have a V shape. So I have my x, my y, and the equation is absolute value plus 1. I'm going to choose my x's. So the typical x, I'm going to have negatives and positives. So I'm going to have -2, -1, 0, 1, and 2. Hopefully that's enough. So I'm going to do absolute value of -2 plus 1. The absolute value of -2 is 2 plus 1, so that gives me 3. The absolute value of -1 plus 1 is 1 plus 1, which gives me 2. The absolute value of 0 plus 1 is still 0 plus 1, so that's 1. The absolute value of 1 plus, there you go. 1 plus 1 is still just 1 plus 1, which is 1. And then the absolute value of positive 2 plus 1 is 2 plus 1, which is, 1 plus 1 is 2, 3. So, because these turn out positive, and the positives still turn out positive, that's why it'll start going down and then it'll sharply go up. So your absolute value should be looking like a Z. If you're drawing it and it just looks like a line, then you need to keep going on the decrease to find where it increases. Luckily for us, this sample is enough. I always start with the sample. If I need more, I'll add to it. So -2, 3, -1, 2, 0, 1, 1, 2, and 2, 3. So it goes down and it goes up. And this is my absolute value, right? So these ones, you need to make sure to create a chart. Start with these sample ones, and then if you need more in order to make that a Z for the absolute value, just add more down there. It doesn't have to be in order as long as you get the graph right. So try page 104, numbers 2 and 11, 104, numbers 2 and 11. I will see you in class.